Welcome back to the SolarPunkPro podcast. I'm James Manzer. And if you want to go from soul-crushing corporate work to a career that actually matters and pays well, stick around to learn how you too can become part of the $4 trillion, that's trillion with a T, dollar a year, electrify everything and power with renewable energy industry. So, podcast statistics say that if you're listening to this, there's a good chance you use electricity. And you plan to continue to use electricity, but you don't know much about how it works besides when you flip a switch, it's there. Or you plug something in, it's like magic when it arrives. But that when you get the bill, the magic of the stuff fades away. Podcast statistics also predict, but you're wondering if there's a way that you can get in on a resource that literally everyone uses. And that includes our friends, artificial intelligence. I mean, is there a buzzier buzzword than AI? Well, our friend AI is a real energy hog, and if this little piggy doesn't get the energy it needs, and soon, the whole AI boom, it is going to topple like a house of cards. Now, maybe today you've got a decent salary, some good benefits, a title that sounds impressive at dinner parties, but then takes you 10 minutes to explain what it is you actually do. You're also exhausted, you're uninspired, and you're secretly terrified that you're wasting the best years of your life moving numbers around in spreadsheets while the world burns down around you. If that sounds familiar, you're in the right place because over the next 20 minutes, I'm going to explain why that feeling isn't weakness or laziness, it's intelligence, and I'm going to show you there's a way out that doesn't involve you taking a pay cut or going back to school for 4 years. Everyone's talking about the AI boom. No one's talking about what powers it. All that artificial intelligence, it runs on very real electricity. ChatGPT, it doesn't dream, it devours. It devours power. Every time you ask a bot for a recipe or a resume, a data center somewhere lights up like a Vegas casino. The next $1 trillion opportunity, it's not NVIDIA, it's not in chips, it's energy. Because if we don't scale renewable power fast enough, the AI boom becomes the next housing bubble. And when this one bursts, they could take the whole grid with it. And today we're going to talk about why the AI is about to eat the world's electricity supply, how the real wealth transfers in kilowatt hours, and why people who know how to build renewable infrastructure are about to become the most valuable workers on Earth. All right, let's start with some math that should terrify every venture capitalist who just wrote a check to an AI startup. A single ChatGPT query, it uses roughly 10 times the electricity of a Google search. Training GPT-4, it consumed about 1.3 gigawatt hours, enough to power 120 homes for an entire year, just to train it once. Think about this, OpenAI isn't just training one model, they're training dozens. Google, Meta, Microsoft, Amazon, they're all in an arms race to build bigger, smarter AI systems. Each generation requires exponentially more computing power, which means exponentially more electricity. Microsoft, Amazon, Google, they're building new data centers at an absolutely insane pace. Bloomberg NEF, it estimates that by 2030, data centers could consume 8% of all US electricity, up from about 2% today. And here's where it gets really interesting, and by interesting, I mean potentially catastrophic. That 8% number assumes current growth rates. If AI adoption accelerates the way these companies are promising investors it will, we're looking at 15 to 20% of total electricity demand just from data centers. Add in electric vehicles, heat pumps, manufacturing reshoring, and everything else we've talked about on this podcast so far, and total US electricity demand could jump 40 to 50% by 2035. And let me put that in perspective. We are talking about adding the equivalent of an entire California power grid every few years for decades. This isn't some distant future problem. Goldman Sachs is projecting that data center power demand will grow at 160% by 2030. That's just 6 years away. And here's the kicker that nobody in Silicon Valley wants to acknowledge. Our grid can't handle this. Not even close. Now, right now, there are over 2,000 gigawatts of renewable and storage projects sitting in interconnection queues, waiting to plug into the grid. That's nearly double our existing total grid capacity, just sitting there, because utilities and regulators move slower than continental drift. The tech companies know this. That's why Google is signing frantic power purchase agreements with offshore wind developers. Why Microsoft is investing in small modular nuclear reactors that don't even exist yet. Why Amazon is buying entire solar farms just to keep their AWS servers from going dark. They're not doing this because they suddenly care about sustainability, though that's what the press releases say. They're doing this because they've run the math and they've realized their entire business model depends on securing power supplies. that don't currently exist. Every AI company is secretly an energy company now. They just don't know how to talk about it publicly because we need to build massive amounts of new power infrastructure. Doesn't sound as sexy as we're building the next artificial general intelligence model. Here's what kills me about this whole situation. The same people who've been telling us for years renewable energy is unreliable and can't scale are now desperately trying to sign contracts for as much renewable energy as they can get their hands on. Why? Because solar and wind are the only things that can be built fast enough to meet their exponential growth projects. Nuclear, easily, at best, 10 to 15 years away. Coal and gas, you can't get a turbine until 2032. Renewables can be deployed in months. The AI boom, it isn't going to be stopped by concerns about sentient robots or job displacement. It's going to be constrained by the boring realities of infrastructure, wires, transformers, generation capacity. And that creates a career opportunity I want you to understand. While everyone's obsessing over who's going to be the next AI unicorn, the real money is going to be made by those that can actually deliver the electrons to power these things. So let's talk about why our electricity infrastructure is completely unprepared for what's coming and why that's actually great news for your career prospects. The US electric grid is basically a museum of 20th century technology still in operation. We're running infrastructure designed for a world where electricity demand was predictable, load curves were consistent, and the biggest concern was whether everyone would turn their air conditioning on at the same time on a hot summer afternoon. That world, it no longer exists. Modern data centers, they don't follow traditional load patterns. They run 24/7 at massive constant loads with the occasional spike when they're training a new model. Electric vehicles, they charge mostly at night, creating new peak demands. Heat pumps draw power all winter when traditional demand was the lowest. Industrial reshoring is bringing manufacturing back to regions where the grid hasn't been upgraded in 40 years. And all of this is hitting infrastructure that was already at the breaking point. According to the American Society of Civil Engineers, 70% of U.S. transmission lines are over 25 years old. Many are over 50 years old. Some are a century. These are systems designed when computers didn't exist, let alone filled entire rooms, and that cloud computing really meant daydreaming. Because here's the brutal reality. Even if we were approving every pending renewable energy project tomorrow, most of them couldn't connect to the grid for 5 to 7 years because we don't have the transmission infrastructure to move that power. We need thousands of miles of new high voltage transmission lines. We need tens of thousands of new transformers. We need smart grid technology that can handle bidirectional power flows and real time load balancing. We need grid scale battery storage to smooth out the intermittency. The American Electric Power Association, they estimate we need to invest 2.5 trillion with a T dollars in grid infrastructure by 2035 just to maintain reliability. That's before we add all this new load from AI, EVs, and electrification. Now, if you're thinking, James, this sounds like a nightmare, you're partially right. From a societal planning perspective, this is a massive challenge. But from a career opportunity perspective, wow, this is the biggest infrastructure build out since the interstate highway system. And unlike highways, which took decades and required massive government coordination, much of this grid expansion is being driven by private capital, desperately trying to secure power for their data centers. Think about what this means. These are companies that are spending billions to build power infrastructure, not because regulations require it, not because they're trying to be good corporate citizens, but because their businesses literally cannot function without it. Microsoft, it is investing in fusion energy research. Fusion energy, it doesn't exist yet because they're that desperate to secure future power supplies. Google is funding offshore wind farms in the Atlantic. Amazon is building solar installations in the desert Southwest. These aren't pilot projects or PR stunts. These are billion-dollar commitments from companies that have calculated their AI ambitions require power supplies that exceed what utilities can reliably provide. And every one of these projects, it needs people who understand electrical systems, energy markets, project management, and grid integration. They need solar installers, electrical engineers, battery storage specialists, transmission line workers, energy traders, and grid software developers. The talent shortage is so severe that companies are offering starting salaries 30 to 40% higher than comparable roles were paying just 5 years ago. They're offering sign on bonuses, relocation packages, and accelerated training programs. Why? because the bottleneck to their growth isn't capital. These companies are swimming in cash. The bottleneck is skilled workers who can actually build and operate the energy infrastructure. So while everyone's worried about AI taking their job, there is this massive growing sector that literally cannot find enough qualified people. And the best part, these jobs can't be automated, they can't be outsourced, and they become more valuable as demand increases. So let's do some back of the envelope math to understand the scale of what needs to be built. And I'm going to show you why this creates specific lucrative career paths. So let's assume AI data centers add 400 terawatt trillion hours per year to US consumption by 2030. That's a conservative estimate based on current growth trajectories. For context, that's roughly the equivalent to adding another Texas to the grid, the entire state's annual electricity consumption. Now, how do we generate an additional 400 terawatt hours annually? Let's look at our options. There's nuclear. One typical nuclear plant outputs about a gigawatt continuously, which means it produces roughly 8.8 terawatt hours per year. So we'd need about 45 new nuclear reactors running full time. At current construction costs at about $15 billion each and 15-year timelines, that's a $500 to $1 trillion investment in a timeline that extends well into 2040s. The AI boom, it can't wait that long. Solar. Now, each gigawatt of solar produces roughly 1.7 terawatt hours per year, depending on location. Each gigawatt, or billion watts, needs 2 million solar panels. So 400 terawatts divided by 1.7 equals about 235 gigawatts of new solar capacity, or about 470 million solar panels. Or wind. With an average 40% capacity factor, we need about 130 gigawatts of wind. That is about 25,000 modern utility-scale turbines. Now, before you say, James, that sounds pretty impossible, let me give you some perspective. The US installed 33 gigawatts of combined solar and wind capacity just last year. If we maintain that pace and focus specifically on powered data centers, we'd hit these numbers no problem, 5 to 8 years. And here's why renewables win this race. They scale fast, they're modular, and they're increasingly cheap. We can build a gigawatt of solar in 6 months, not 6 years. Wind farms can be operational in 12 to 18 months. Compare that to a decade for nuclear or the permitting nightmare of adding new fossil fuel plants. And here's the critical piece most people miss. It's not just about total generation capacity, it's about peak demand management. Here's where it gets really interesting from a career perspective. In markets that I'm in, like in here in New England, about 40% of my electric bill pays for less than 8% of the actual electrons I use. Those charges cover peak infrastructure, the generators, the transmission lines, and the substations that only run a few hours each year, or worse, a few hours each decade when demand spikes. The electric grid is built to always be able to handle the absolute high demand, even if that demand only happens for a few dozen hours a year. It's like building a 10-lane highway because once a year, there's a huge traffic jam, even though it's mostly empty the rest of the year. A study from Stanford and NREL found something fascinating. If large data centers were willing to throttle AI workloads for just 160 hours per year, that's less than a week total, the grid could absorb almost all their new demand without massive infrastructure expansion. Why? Because most hours of most days, we actually have plenty of generation capacity. It's those peak hours, typically hot summer afternoons and cold winter evenings, that force us to build and maintain expensive infrastructure that sits idle most of the time. This creates a massive business opportunity. Demand flexibility management. Companies like Voltus, C-Power, and Enernoc are paying commercial industrial customers to reduce load during peak demands. Some facilities are earning somewhere between $50 to $500,000 annually just for being willing to shift their electricity use by a few hours. And here's where your career comes in. Demand response specialists, they are earning anywhere between $100,000 and $140,000 a year managing these programs. They work with large electricity users to identify when and how they can reduce load without disrupting operations. Or energy trading analysts at companies like NLX and Schneider Electric. They can make anywhere between $100,000 and $175,000 a year managing portfolios of flexible load and generation assets, essentially arbitraging electricity prices in real time. Industrial energy managers are making between $100 and $160,000 a year helping manufacturers, data centers, and other large users optimize their electricity consumption, often saving companies millions annually. Grid optimization software engineers at companies like AutoGrid and STEM earn $150,000 to $250,000 a year building the algorithms that coordinate millions of distributed energy resources. These are not theoretical future jobs. These are companies hiring right now and struggling to find qualified candidates. And here's what I want you to know and understand. You don't need an electrical engineering degree to break into this field. Many of these roles, they value operations management experience or data analyst skills or industrial process knowledge or facility management background. If you've worked in manufacturing, data center operations, facility management, or industrial processes, you already understand the operational side. We can teach you the energy piece. That's exactly what our masterclass does. It takes your existing skills and shows you how to translate them into high-paying careers. Now let's talk about the solution that actually works and why it creates more career opportunities than any other approach. The old model of electricity was simple. Build giant power plants far away from cities, run high voltage transmission lines to bring the power to where it's needed, step it down through substations and transformers, and distribute it to homes and businesses. That model, it's dying. And AI is helping kill it, ironically, while also desperately needing its replacement. The future is distributed energy resources, or DERs. Instead of building 50 giant power plants, we build 5 million mini plants, rooftop solar, community solar farms, battery storage systems, smart EV chargers, backup generators, and controllable loads. When you aggregate millions of these small resources, they act like a massive virtual power plant, except they're more resilient, more flexible, and cheaper to deploy than centralized generation. Think of it like the difference between a mainframe computing and cloud computing, or a landline phone versus mobile phones. The distributed model wins because it's more adaptable, more resilient, and scales better. Here's a real example. During the Texas freeze in 2021, when centralized power plants failed and millions lost power, homes with solar and battery systems, they kept running. Not because solar panels work better in the freeze, but because distributed systems with storage are inherently more resilient than centralized systems. Virtual power plants are already operating at scale. Green Mountain Power in Vermont has enrolled 2,000 Tesla Powerwalls into a VPP. During peak demand, instead of firing up some expensive fossil-fueled gas peaker, they dispatch these home batteries. Participating homeowners make $500 to $1,500 per year just for letting the utility occasionally to use their battery. In California, tens of thousands of smart water heaters, EV chargers, and thermostats are participating in demand response programs. They automatically adjust when electricity is cheap, which is when midday solar is peaking, versus expensive in the evening power. Participants, they save 50% of their energy costs without changing their lifestyle. And here's where AI actually becomes part of the solution instead of the problem. Machine learning models can forecast weather patterns, predict electricity demand, optimize battery charge-discharge cycles, and dispatch thousands of distributed resources in milliseconds. We're using AI to manage the energy system that powers AI. And there's kind of a beautiful symmetry to that, don't you think? Companies like STEM, AutoGrid, and Virtual Peaker are building software platforms that aggregate and optimize these distributed resources. They're creating what's essentially an operating system for the electric grid, and they need software developers, data scientists, and system operators who understand both energy markets and technology. And here's the career path that excites me most. Many of these roles have a clear progression into business ownership. I personally know dozens of people who started as solar installers, learned the business, and now own companies doing $2 to $5 million in annual revenue. One former coworker is running his own commercial solar installation company, bringing home $20 million a year. Think about this opportunity. You could start as a solar installer. You could make $80,000 a year, gain experience for a couple of years while getting every relevant certification. Then start your own company. Within 5 to 7 years, you could be running a business doing millions in revenue while employing dozens of people and building critical infrastructure. It's not a fantasy. That's a documented career path that hundreds of people are following right now. And the AI boom, it's accelerating all this because tech companies need distributed energy to stabilize the grid their data centers depend on. They're funding pilot projects. They're investing in VPP platforms. They're signing contracts with distributed energy developers. Your opportunity isn't in competing with AI for coding jobs. Your opportunity is in building the physical infrastructure that AI cannot exist without. All right, so let's talk about money, because understanding where capital is flowing tells you where the opportunities are. Everyone is obsessing over AI stocks. Nvidia, Microsoft, Google, up, down, left, right. And yes, the companies are making money. But you know what their real constraint is? It's not processors, it's not data, it's not algorithms, it's electricity. If you want to invest in the AI revolution, you don't buy GPU manufacturers, you buy generation, transmission, and storage, because every new data center requires massive new power infrastructure. And that infrastructure is where the actual constrained resource is. Goldman Sachs projects $3 trillion a year in clean energy infrastructure spending between now and 2030, largely driven by digital demand, not climate policy, not consumer demand, corporate data centers desperately securing power supplies. Think about the pattern in every technological revolution. The railroad boom, it made fortunes for steel manufacturers, coal suppliers, and land developers, not necessarily the railroad companies themselves. The internet boom made fortunes for data center REITs, fiber optic companies, and equipment manufacturers, while many .coms went bust. The AI boom, it will make fortunes for people who provide reliable, scalable electricity, while many AI startups will fail when they can't secure power for their servers. This is the classic picks and shovels play. During a gold rush, you don't invest in prospectors, you invest in the people selling the shovels. During the AI boom, you don't invest in chatbots, you invest in the infrastructure that powers them. All right, let's bring this home with what you can actually do about it. Everything I've described, the infrastructure build out, the distributed energy revolution, the AI driven demand, creates specific, immediate career opportunities. You don't need to wait for perfect conditions. You don't need a PhD in electrical engineering. You don't need to start over from scratch. Here's what you do need to understand. The skills gap in renewable energy is so severe that companies are hiring people from adjacent industries and training them on the job. So if you work in IT or software, your skills in network architecture, system optimization, and database management translate directly to energy management platforms and smart grid systems. If you work in project management, your ability to coordinate timelines, stakeholders, and budgets is exactly what solar developers and transmission companies need. If you work in sales, complex B2B sales skills, they transfer perfectly to selling energy systems, PPA contracts, and grid services. If you work in finance or accounting, your understanding of cash flows, project finance, and risk analysis is critical for renewable energy development and investment. If you work in operations or manufacturing, your process improvement and quality control experience is needed in solar manufacturing, battery production, and installation companies. If you're in the trades, HVAC, electrical, plumbing, you're literally one certification away from dramatically increasing your income by specializing in heat pump, solar installation, or battery storage. Early movers capture disproportionate value. The people getting into renewable energy now will be the senior staff, the business owners, and the industry experts 5 years from now. While everyone else is worrying about AI taking their jobs, you could be building infrastructure that AI can't exist without, getting paid well to do it, and positioning yourself in an industry with decades of growth ahead. The AI revolution needs energy. Energy needs workers, and workers who understand this connection are about to become some of the most valuable professionals on Earth. Here's what I want you to take away from today's episode. AI, she's power hungry. And it isn't a problem, it's your opportunity. The same boom everyone's celebrating is creating urgent demand for exactly the kind of infrastructure work that can't be automated or outsourced. While everyone's trying to become prompt engineers or learn Python, the real constraint, the actual bottleneck to the entire digital economy, is electricity. And electricity requires people who can generate it, store it, move it, and optimize it. And that is where you come in. So here's what you do next. First, if you're wondering whether you're actually burned out or you just need a change, take our free quiz at SolarPunkPro.com. 3 minutes, and you'll get clarity on whether this is temporary frustration or a signal you need to make a move. Second, book a free 30-minute industry analysis call with me. I'll map out the specific AI-driven energy jobs in your region, the companies that are hiring, the salary ranges you can expect, the fastest path from where you are today to where you want to be. Third, download my 100 careers that will power the future guide. This isn't some generic career advice. This is 100 specific roles with real salary data organized by the skills you already have. Whether you're in IT, sales, project management, or trades, I'll show you exactly how your experience translates to energy careers. Because here's the bottom line, the AI boom, it is real. The energy constraints, they are real. And the opportunities for people who understand this connection, they are real and massive. 3 years from now, you'll either be part of building the infrastructure that powers the AI economy, or you'll be watching other people build it while you wonder, what if? The AI revolution doesn't run on algorithms, it runs on electrons. And the people who deliver those electrons are about to have a very good decade. I'm James Mancher. This has been the SolarPunkPro podcast. Remember, we're here for a good time, not a long time. If you are going to spend 40 plus hours a week working, it might as well be building the future instead of watching it happen. Now, let's go get you plugged in.